Okay, so we're going to start today by doing a warm-up from yesterday. And so if you wanted to pause the video, you can at this point. Give the students a couple of minutes to copy these questions down, and then we'll take them up in a second. Okay, so the big thing that we learned and reminded ourselves of the work we did in grade 11 is that to solve these exponential equations, we have to find a common base. We know these are exponential equations because the exponent is, or sorry, the unknown is up in the exponent. So our strategy is to find a common base. In the first example, we see that 125 can be, or 1 over 125 can be expressed as a base 5. You could do it in 2 steps, or hopefully you can do it in 1. I'll do it in 2 steps just to make sure you follow. So first I'll change the 125 to 5 to the power of 3. But then recognizing if it's on the bottom, it can go on the top and have a negative exponent. Again, I would hope that we can see that 5 to the negative 3 gets us 1 over 125. We can go straight to there. Regardless, we now have a common base, and since they have the same base, we can ignore the bases and go straight to the exponents. Make sure we put that therefore part. So we'll say therefore 2n plus 5 equals negative 3. A little bit of algebra. And we get n equals 2. So in that example, we already had the 5, and so we could change the other one to a base 5. In the next example, we might recognize that you need to find some other new base. It's tempting to look at it and change 32 into base 16. A common mistake is people tell me that it's 16 squared, but 16 squared is way bigger than 32. So instead we got to find another common base, and in our case I think 2 would be a good common base. So I'm going to change 16 first to 2 to the power of 4, and then I'll deal with the exponent in a moment. And 32 is 2 to the power of 5. Dealing with that exponent in a moment. And now on the left side and the right side, I have a situation where I have 1 base, but 2 exponents. So we have a little mini rainbow happening here. Keeping that base of 2, rainbow this, we get 12 plus 4x. Same rainbow happening over here, except with a 5. So 2 to the 5 minus 10x. Again, now we have common bases. So we can ignore the bases and look simply at the exponents and say it's 12 plus 4x equals 5 minus 10x. Again, notice I remembered my therefore statement. Rearrange to get x on one side, numbers on the other side. I think I'll bring the minus 10 over here and make it a plus 10. With the 4, it gets a 14. I'll leave the 5 there and minus 12, and we'll get negative 7. Divide both sides by 14. Negative 7 over 14. So x equals negative 1/2. So hopefully you got that from yesterday's lesson and be able to remember this is the stuff that we did in grade 10 to solve exponential equations.